Sketch on the same axes in the interval from 0 to 180 the graphs of y equals tan x and y equals 2 cos x. So let's do the 2 cos x first. So I'm going to draw the cos graph and then I'm going to multiply the y coordinates by 2 because of the 2 at the front there. So I know the cos graph usually starts at 1, goes down to 0 at 90 degrees, and then goes down to -1 at 180. I am now just going to multiply all of the y coordinates by 2 because of the 2 at the front there. So instead of going through 1 on the y-axis at 0, it's going to go through 2. It's then still going to go down to 0 here at 90 degrees, because 2 times 0 is still 0. And then instead of going down to -1 at 180, it's going to go down to -2 at 180. So in red here, we've got the graph of 2 cos x. Now we're going to draw the tan graph. Now I know for the tan graph I need to put asymptotes in, so there's an asymptote at 90. And I know there would be another asymptote over here at 270. I know the tan graph starts at 0 and then goes up towards the asymptote here and then keeps going up. And then it looks like this on the negative part. So there is my graph of y equals tan x and y equals 2 cos x between 0 and 180 degrees. Part B. Show that tan x equals 2 cos x can be written in that form. Well, first let me take the tan x, and I'm going to rewrite that as sine x over cos x. I'm then going to multiply both sides by cos x. So 2 cos x times cos x is 2 cos squared x. And now the cos squared, I'm going to replace that with 1 minus sine squared. Expanding the brackets. And moving everything onto one side. And that is the form that we needed. So that's part B. Part C. Solving this quadratic equation, because I know that this is the same as this. I've just shown there the same thing, so I could just solve the quadratic. If I solve the quadratic, I find that sine x is going to equal -1 plus or minus root 17 over 4. We can do that with either the quadratic formula, or I can do that with the quadratic solver on your calculator. So, the -1 minus root 17 all over 4, that is less than -1. So I know that's not going to give me any solutions. So I can actually ignore that one and just focus on the positive version. If I do sine inverse of that, my calculator gives me 51.3 degrees, which I can then draw a quick sine graph We're only going up to 180 degrees here. So here's my sine graph. We had our first solution. Here there'll be another solution here. We know this is 51.3, So this is going to be 51.3. And so if I do 180, take away 51.3, I get 128.7. And these are my two answers to that equation.